Good morning, good afternoon, and good evening. Hello and welcome to Reimagining Motion, a podcast from the High Volume Transport Applied Research Program, which is undertaking research into the complex and interrelated issues of sustainable transport across Africa and South Asia. The High Volume Transport Applied Research Program, HVT, is an £18 million investment by the UK Foreign, Commonwealth and Development Office, FCDO. I'm Holger Dogman, your host for today's session. Welcome. The efficient movement of people and goods around countries is the bedrock of growing economies. As we've seen in recent years with the COVID-19 pandemic, when people stop moving, our economies quite literally grind to a halt. Infrastructure need to be robust and fit for purpose. One of the most pressing challenges to our roads and rail begin fit for purpose is a climate crisis. Transport infrastructure is extremely vulnerable to climate change, and the impact of extreme weather events, especially those in low-income countries where climate change is most actually felt. Heat waves cause railway lines to buckle, flooding cuts of roads and supply chains. It's essential that infrastructure need to be built that are resilient and that reduce carbon emissions. This is not an easy task. Building roads and rail is expensive, difficult, and requires long-term commitment and vision. Planning for the needs of public transport, pedestrians and cyclists needs specific consideration and investment. How then LMICs build infrastructure that are inclusive, greener and resilient, everything from road to rail, from public transport to walking and cycling. In this podcast series, we'll discuss the specific challenges and opportunities for these key land-based modes and share latest research and tools for the future of transport infrastructure. Today, I'm speaking to Andrew Otto. Andrew is a practice lead of the International Pavement Engineering team at the Transport Research Laboratory, TRL. He is a highly experienced UK chartered engineer and a fellow of the Chartered Institution of Highways and Transportation with wide-ranging experience in materials and pavements. In fact, also he is joining us today from Kenya. He has an MSc in engineering and more than 20 years experience in engineering. He has worked on numerous projects in tropical countries involving road material research, pavement analysis and design, and pavement investigations and evaluation. He has been an author and co-author of many manuals, guidelines, material specification and road construction methods. He has authored several research publications and reports, and he is also the team leader for the Road Note 31, which we also spent a little bit of time on today, where he wrote several chapters and led a team of authors. Lastly, Andrew is a trainer in the use of the Highway Development and Management tool, also known as HM4. So, good morning, Andrew. How are you doing?
Good morning. I'm well, thanks. I hope you're doing well too. I'm happy to be invited on this podcast.
Thanks, Andrew, and thanks also for joining us. So let's dive immediately into that. We will later talk particularly around climate change, but let me start by asking you to give us a sense of all the other changes and challenges in recent years which need to be factored when a highway engineer in a low and middle income countries consider the building and maintenance of roads.
Yeah, thank you. Over recent years, there's been several changes to the road environment, and the road designer or road engineer has to take these into account. One of the most significant change, other than climate change, is in the vehicle types that are now available in low and middle income countries. The trucks that are now present on the network are much more powerful than those that were present over 30 years ago when we had the fourth edition of Road Note 31. We now have trucks that are capable of carrying all the legal limit of loads without actually feeling much stress in the engine. And as a result of this, they tend to overload. Now, even the trucks which are within the load limits are now using super single tires or the wide base tires, other than having, for example, 4 tires on one load axle. They can now run with 2 tires on a single axle. And as you can imagine, and that causes a lot of stress on the pavement as compared to when you have 4 tires. From the old lessons of physics, pressure, the smaller the area, the higher the pressure. So that is one key change other than climate change. The other major change over the years has been in the frequency by which these trucks and heavy vehicles use the roads. Because the numbers have increased, it means that in any vehicle stream, you're likely going to find more heavily loaded vehicles or trucks within the stream. So from, say, previously having about 5% in the stream, we now talk of having 10% of vehicles in any traffic stream are typically trucks carrying heavy loads.
Thanks, Andrew. So really highlighting the changes, particularly on the freight side, with more heavier types of trucks, and also changes in terms of the numbers, in fact, of those. What is about also in terms of the improvement and changes of the materials of the road? And are there any other technological changes when it comes to road building and maintenance?
Yeah, thank you. In terms of materials, a lot has happened, and the growth in knowledge is probably exponential when you think of it. When I was a student, if you went about searching for literature on a given topic, you would be lucky if you came across 10 papers on a given topic. But now, if you hit Google on any topic, you'll run into hundreds of thousands of such papers. Now, this is a proxy for how much research is actually going on the material side of things. Now, not all the research makes it through successfully into something that's implementable. But there has been several materials that have come through in pavement engineering that are now of very great importance and use in improving the level of service and extending the life of the roads. Some of these include the use of stone mastic asphalt. I'm aware that this material came several years ago, but through further research, it has been redesigned to an extent where it is now really, really good to resist deformation on roads. And as I said earlier about the increase in truck loads and frequency, such materials are now of great importance as well. Now, on the technology side of it, the growth of computers and microprocessors has actually enabled the way in which we understand the behavior of materials, the behavior of roads, what factors are affecting the performance. And with such technology, we are now actually able to understand, for instance, that most roads, when they're designed to carry a certain threshold of traffic, typically about 80 million repetitions, standard, don't need to actually add any pavement strength to it because the stresses on the natural material become much, much less. And you only have to worry about the top of the road. You don't have to worry about what is below the top of the road, the top few centimeters of the road. So these are some advances which were not previously captured in the 4th edition of Road Note 31 that we have now incorporated in the 5th edition.
Thanks, Andrew. And we will talk more about the details of the road note in a minute. But let's move a little bit more towards the issues of climate change. And we have seen in the last years more extreme weather events, particularly in the low and middle income countries. So tell us a little bit more what threat and problems is climate change having on our road infrastructure, and what example of this are we seeing?
Climate change is here, and it's possibly come sooner than the infrastructure sector has been prepared for. Typically, in tropical and subtropical countries, the biggest change that is being noticed right now is the increase in rainfall intensity and the disparity or the change of the intervals at which the rainfall now comes. For instance, areas that typically, say, used to receive 2 peaks of rainfall receive in a year now receive one very high peak of rainfall, and vice versa. Others that used to receive only one peak of rainfall in a year now can receive two or more, and with very high intensity. Now, as you can imagine, the effect that this would have on a structure such as a road pavement that is typically tied to the earth, it's going to be affected when there is more cycles of wetting and drying. There's going to be a change in its behavior. And this actually manifests in deterioration of materials that are used in the road pavement. Typically, because of the increased intensity of the rainfall, you have washouts that are now being experienced in areas that never received washouts. That is a typical pavement structure gets taken out by increased runoff. Last year, or perhaps early this year, there were several events in countries like Zambia and Malawi got a large part of the infrastructure taken out. In Uganda, for instance, there was a major link in a major corridor that really got a bridge lifted up and carried away by this increase in the rainfall intensity. At the same time, we also have the gradual increase in the rainfall quantity, not necessarily the intensity, but the quantity received per year. Now, when this happens, it means you have more water standing around. So this water standing around for longer gets taken up by the road materials through capillary action, and hence ends up softening the road materials and making it fail earlier. On the flip side, we also have the increase in global temperatures. Now, tropical and subtropical countries have been having high temperatures, but that's not to say that those high temperatures are not increasing. So the increase in these temperatures means the bitumen or the asphalt roads tend to soften more easily under load from trucks. And bear in mind that some of these trucks are actually very heavily loaded. So it means that an intervention, which right now may not be easily seen, will come into play in a shorter period of time. If typically the maintenance or resurfacing cycle was, say, every 15 years, now the resurfacing cycle will be shorter. It will be about 10 years. So someone looking at their road today may say, oh, no, there's absolutely no problem with it, not realizing that this effect is accumulating and suddenly you have it happening shorter. So in brief, that's what we're seeing in terms of the climate effects.
The climate effects in terms of more heavy rainfall, in terms of really putting us more pressure and also in terms of heat on the road, then there's the challenge to really also maintain those roads as well as to build new roads. So you mentioned at the beginning the Road Note 31. So it's a guide to the structural design of surface roads in tropical and subtropical regions. So it's in fact also the first update after over 20 years, which, as we heard, so much has changed. The Road Note is an important tool for road engineering. So first of all, let me thank you also for doing with your team at TRL also the work and for doing us the update. Maybe you can share a little bit more about what the Road Note 31 is and get us in some details.
Yeah, thank you. Road Note 31, and thank you for reading out the full title, so I won't repeat it. Anybody who is quite keen will notice that there's a slight change in the title from the 4th edition. For starters, the 4th edition talked of bitumen surface roads. Now we're talking of surface roads, so it means we're no longer talking only about bituminous roads. Then a second change in the title was, in the 4th edition, we were talking of tropical and subtropical countries. Now we're talking of tropical and subtropical regions. The understanding being that in some countries, you can have several climatic zones. So if you say in a country, then some countries say, I don't have fully tropical, I don't have fully subtropical, I have a bit of temperate, so this does not apply to me. So we're basically talking of regions within the country. It is Road Note 31 is a guide that is targeted at road pavement designers at road planners in the various roads agencies so that they can make informed decisions as to, for example, how to enhance the climate resilience of the infrastructure of the roads that they're building now and in the near future, and also in the rehabilitation of the roads that are now existing. It is a guide, and in being a guide, it means that it can be used along with other already existing country manuals or road agency manuals. And it can also be used alone, independent of any of these. So it sits in a very nice spot. It's a well thought out document, and I would really encourage anybody that's taking up a road design project to actually make use of it.
So, Andrew, you worked also in the past with an FCDO-funded program called RECAP, which focus on low-volume roads. Is the Road Note 31 just relevant for highways, or does it also capture the challenges, particular for rural roads?
Yes, thank you very much for bringing this up. The RECAP program was sort of a precursor to the HVT. RECAP program focused a lot on rural roads, which tend to be of low volume in terms of traffic. And in the RECAP program, a lot of research was targeted at how to make low volume roads, rural roads, more sustainable and more affordable. Now, several of those research projects yielded results, and the results of these have actually been incorporated in Road Note 31. Now, we have incorporated them in such a way that we shouldn't kill off the RECAP documents. So the documents produced during RECAP are still valid as they explore in greater detail some of the research or some of the materials behaviors or pavement behaviors. But a key bit of the RECAP research that was incorporated in Road Note 31 was the revised pavement structures and material specifications for low volume sealed roads. So these have been incorporated in Road Note 31 as they were found to be more sustainable and more affordable for low volume roads. That's roads that are designed to carry less or equal to 1 million repetitions of a standard axle over their design life.
Thanks for sharing that, Andrew. Going back to the issue of climate change, so talk us through how Road Note 31 includes guidance around also the specific design and also how you consider climate resilience.
Actually, when you look at the cover page of the Road Note 31 5th edition, you'll notice there's in a slightly smaller font, but you can't miss it. And there's a sentence there.
Take your glasses on.
There's a sentence there, integrating climate resilience into road networks. So there's been a lot of emphasis on having that integrated within the Road Note 31. So, for instance, the moisture content at which we assess the strength of the natural soil that carries all this road infrastructure and the vehicles that run on it. Previously, we used to assess this at lower moisture content, but now we are assessing the strength at 4 days of soaking of that material in water. So in other words, when you look at it, if there was a climate event in which that soil got inundated in water for 2 or 3 or 4 days at least, you expect that the road should be able to withstand that. Whereas previously, the designs were possibly handling a day of such soaking or not even soaking at all. So we have changed the strength, the moisture content at which the strength is assessed. Now, going further, we have also integrated something that covers both climate resilience and sustainability in terms of how the runoff from the road pavement is carried through safely into receiving streams. There will be sections of any given road. I'm not saying it's the whole road. There will be sections where you have severe runoffs that could actually cause a lot of erosion downstream of farms that are nearby the roads. And bear in mind also that as vehicles use the road, the tires of the vehicles degrade and create several tiny particles, which you may not be able to see with the naked eye over a single pass, but over several passes, these accumulate and they're washed with this runoff into receiving streams. And of course, we use water from these streams for personal consumption and for crops. So we had to find a way of dealing with this dual challenge of the increased runoff as well as the particulates that come off it. So in the Road Note 31, we have in Chapter 7, you'll find that we have devised several methods of dealing with this. We refer to them as sustainable drainage systems, together with very nice sketches of what they do or how to build them. And these help a lot in that aspect of sustainability, as well as dealing with this increased runoff that's coming off. So as a result, you're protecting both the road pavement as well as the surrounding areas and aquatic life as well. Now, also in terms of the pavement structure itself, we have now incorporated the use of concrete pavements, commonly referred to as rigid pavements. Now, concrete pavements withstand climate change effects better than the flexible asphalt concrete pavements. They withstand them better. They withstand heavy loads better. And so in cases of overloading, you're better off with a concrete pavement than a flexible pavement. But we have also not forgotten to enhance the design of flexible pavements to be able to withstand effects of climate change. We have introduced through some experience that was gained from New Zealand, the use of epoxy modified asphalt. So epoxies are quite resilient resins that can withstand very high temperatures without deforming and also offer a really tight water seal. So they prevent the ingress of water into a pavement. When temperatures go higher, they retain their shape so the pavement doesn't deform.
So Andrew, you highlighted also the importance in these days to really make also roads more resilient, dealing also with the pressure of climate change. Beyond the work on specific knowledge product, what else also need to be done? Is there in fact also enough awareness from in the agencies or in policy making? Do we have enough research? So where do you see also the key elements of really scaling this issue and mainstreaming the issue of climate resilience in road building?
Now, the challenge they're facing is that there is a lack of policy that makes this a systematic approach. And as well, sometimes climate resilient design are sometimes expensive compared to the standard designs. But on the flip side, there are also designs, climate resilient designs, that are actually cheaper than standard designs. The knowledge is in knowing when to apply which technology where, and you can end up actually having a much more cost-effective option than the standard design.
So let's look forward, let's say not 20 years, but in 10 years. So what, from your experience, will be in Road Note 31 in 10 years from now? So talk us through a little bit about this. What are the big topics which might need to be addressed by research as well as by policy in the coming 10 years? And you mentioned already climate mitigation as a core one.
Yeah, thank you. Thank you for that. According to the feedback that I've received, and what I'm seeing through everyday practice, there is need to emphasize research into recycling of materials. Recycling from within the road sector itself and from outside the road sector, say from building construction and others. The reason for that is recycling is going to offer a more sustainable way of providing infrastructure or maintaining infrastructure with less impact on the environment. At the same time, recycling is going to enhance the reduction in carbon footprints of various technologies. But the challenge that we have now is that not much classification has been done in recycling of materials or the grades of recycled materials, so that a designer can say, this is, say, grade 2 recycled material, and I can use it like this and this. So there's need for research in that aspect. The other area where we need to really, the sector really needs to dive deep in, is the incorporation of artificial intelligence in understanding the behavior of pavements, the behavior of materials, the behavior of their users, so that we provide really appropriate solutions, so that you don't under-provide and you don't over-provide. We are now at a critical stage where the world needs to be very mindful of resource use, and therefore appropriate resource use has to be in place. In terms of policy and regulation, as I said earlier, there's need to strengthen the policies that emphasize climate resilience, the use of climate resilient options in road provision. But there's also a need for almost a regulation that each road agency should at least undertake construction or some research trials in any network that they are working on. Now, the fear has been among us engineers that if you build a research section and it doesn't perform as expected, you could face litigation and all of that. So there's that aspect of the policy that needs to be adjusted so that these roads agencies are empowered to include research sections which are properly designated, so that no one gets penalized if it doesn't perform well. But if it performs very well, then they should be given a pat on the back or some kind of an incentive.
Thank you, Andrew. We're almost at the end of our podcast, and thank you so much for sharing your insight and your experience. Are there any final words you want to share with our listeners?
My final words relate to two aspects, really. Number one is the issue of the carbon footprint of whatever technologies we're adopting. We really need to be mindful of that, so that we don't get into that vicious cycle. We also, in that respect, should take up initiatives of trying to at least reduce the carbon footprint of the sector. The second last few words that we should not despair in our quest for climate resilience and provision of cost-effective infrastructure. There are so many things we use today which started off as very crude tools. I don't think you and I 20 years ago ever thought that we would be seated on very different parts of this globe and having real-time conversation and video at the same time, looking at each other. So we should not despair in this quest. Several decades, we look back and say, oh, do you remember the days when we used to talk about reducing carbon footprint? Something like that.
Thanks, Andrew, for sharing that and really highlighting that we are just at the beginning on tackling also the impacts of climate change and have to make also our infrastructure more resilient. There is a responsibility in terms of looking into the opportunities for mitigation at the same time. Thanks for sharing so much of your insights. It was a real pleasure talking to you, and hope we can speak then also in 20 years again. So good luck for your research and your excellent work, and it was a pleasure talking to you. So thank you for listening to this episode. If you'd like to find out more about the work of our guests and any of the resources, please check out the links in the description. I also encourage you to listen to the other episodes in the series. Also, you can leave us a rating, hopefully a good one, and a review. It really helps others find our podcast. If you'd like to learn more about the work of High Volume Transport, you can check out our website at transport-links.com or follow us on Twitter at transport_links or on LinkedIn at High Volume Transport Applied Research Program. The High Volume Transport Applied Research Program, HVT, is an £18 million investment by the UK Foreign Commonwealth and Development Office, FCDO. The program's new body of research aims to help inform decisions of policymakers in low-income countries and make road and rail transport greener, safer, and more accessible and affordable. My name is Holger Dogman, and you have been listening to Reimagining Motion. Thank you. Stay and travel safe wherever you are. Goodbye and auf Wiedersehen.